Now this question is based on the identification of isostructural and isoelectronic pairs. The question asked is identify the isostructural and isoelectronic pairs from the following species. They would have given 4 different choices, meddling with the combinations. First we have to recall what is meant by isoelectronic. Isoelectronic means species with the same number of electrons. Isostructural means species with a similar shape or similar structure. Iso means same. Same number of electrons means isoelectronic. Same structure means isostructural. First, let us see the number of electrons in all the cases. First, chlorate, ClO3 minus. Chlorine atomic number is 17. So, number of electrons is 17 plus 3 oxygens are there. One oxygen atomic number is 8 plus anionic negative charge due to 1 electron. So, 3 8s are 24 plus 17, 41 plus 1, 42 electrons are there. First, let us concentrate on the aspect of isoelectronic system. So, 42 electrons are there. Here sulfur atomic number is 16 and it contains 3 oxygen atoms and 2 negative charges. 16, each oxygen atom is atomic number is 8 plus 2 electrons for 2 negative charges. So, 3 8s are 24 plus 16 40 plus 2 42 electrons. Now coming to the case of carbonate, carbon atomic number is 6 plus 3 oxygens, each with atomic number or number of protons or number of electrons is 8. So 3 into 8 plus 2 negative charges because they contain 2 electrons. So 24, 30, 3 8s are 24 plus 6, 30 plus 2, 32 electrons. So 32 electrons. Lastly, nitrate anion. Nitrate, nitrogen atomic number is 7. So 7 plus 3 into 8 plus negative charge due to 1 electron. So 3 8s are 24 plus 7 31 plus 1 32. So last 2 species are isoelectronic. With the sense they have same number of electrons 32. First 2 species are isoelectronic. In the sense they have 42 electrons. Now let us analyze the structure ClO3 minus. ClO3 minus. This will be the structure. ClO3 minus. Carbon outermost halogens are 5th chlorine. Outermost halogens are 7th group elements. 7th group S2P5 configuration. Outermost electrons is 5. So 5 electrons are shared in this manner. 1, 2, 3, 4, 5. It is sharing. Oxygen electron everywhere coming. Oxygen valency shows 2. So it also shares. ClO3 minus. This is the structure of chlorate. Sulfate. This one is SULPHITE. Sulfite. Sulfate is SO4 2 minus. This one is SO3 2 minus. SO3 2 minus has the structure in this form. Yes. Double bond O minus, O minus. Yes, 1, 2, 3, SO3, 2 charges are there, SO3 2 minus. Carbonate 2 minus in a similar manner. So, C double bond O plus 2 O minus linkages. Nitrate, the structure of nitrate. So, this is the structure of nitrate. So, everywhere it contains depending upon the negative charge. So, chlorate. So, you have to be careful about the spelling. CHLORATE, chlorate. This one sulfite. This is carbonate we know. This is nitrate, NITRATE, nitrate. So, this is the arrangement. ClO3 minus SO3 2 minus CO3 2 minus and NO3 minus. So nitrogen shows the valency of 3 as well as 5. nitrogen, phosphorus, arsenic, antimony, bismuth. They will show the valency of 3 as well as 5. 5 here it is 1, 2, 3, 4, 5 valency. Oxygen showing the valency of 2. So that is why it is, in some cases it is existing as negative linkage. That is to be noted. Now these are of similar pattern. Number of these two will be of pyramidal shape. These two will be of pyramidal shape, and these two, that is chlorate anion, sulfite anion will be of the shape pyramid. So we have to distinguish between pyramid and tetrahedron. Tetrahedron is consisting of all triangles of equal size. Tetrahedron, 4 triangles of equal size, but excepting the base triangle, other 3 triangles are different, means that is called pyramid. If you have pyramid above and below the plane of a square or triangle, it is called bipyramid. Square pyramid, square bipyramidal, trigonal pyramid, trigonal bipyramid, like that. Now carbonate and nitrate, their structure is trigonal planar. Trigonal gonal means angle. Triangle or trigone both mean the same. Triangular planar. This is one carbon at the central atom. 3 vertices of the triangles are the oxygen. 2 with the negative charges. So if you combine the dotted lines, that will refer to trigonal planar. That is, carbonate is trigonal planar. Similarly is the case with the nitrate. Nitrate also trigonal planar. This method, trigonal planar. But these two, first two are pyramids. Pyramids means 3-dimensional version with triangular shapes. So here as usual, the dotted lines denote the geometry. Solid lines denote the linkage. So pyramid means it has a triangular base and sides also triangle. So in common method, 2-dimensional view, it will be looking like a triangle with a center point connected together by means. But the sides and the relative sides are of importance. Pyramid and tetrahedron. Pyramid and tetrahedron. Tetrahedron means made up of all equal triangles. Pyramid means side triangles, 3 triangles are of different size than the base triangle. So here these two are trigonal planar structure. These two are pyramidal structure. Pyramidal means it is spatial. It is non-planar. Spatial or non-planar. Trigonal is planar. All are made up of triangles only. But the question is to be noted. Last two, carbonates and nitrates are planar species, whereas chlorates and sulfites are non-planar species. Essentially all of them form the vertices of a triangle. So different triangles, how they are oriented, whether they are planar or non-planar, that is to be noted. So as far as this question is concerned, the correct choice is that chlorates and sulfites are isoelectronic, that is with the same number of 42 electrons. They are isostructural with the same pyramidal structure, whereas carbonate and nitrate species are isoelectronic with 32 electrons in them, and they are isostructural, they have the trigonal planar structure. So this finishes this thing. First two directly given as isostructural and isoelectronic, that is chlorates and sulfates are isostructural and isoelectronic. Similarly carbonates and nitrates isoelectronic and isostructural. Here we have to bear it in mind that isoelectronic means same number of electrons in a system, whereas isostructural means how the as per the valence shell electron pair repulsion theory, the bonds how they are distributed. So they are planar arrangement or non-planar arrangement. Pyramidal means non-planar arrangement. Trigonal planar means, as the name implies, it is a planar arrangement. So that is to be noted with respect to this question. Now this is another question based on the same hybridization, that is VS EP or theory, valence shell electron pair repulsion theory, which describes the shapes of molecules as well as the mode of hybridization. So, similar questions we have seen. The additional aspect about this compound is it is a compound of inert gas. So, inert gases, xenon is inert gas, means it is not reactive, but fluorine is highly reactive in the sense that it will attack even the inert gas to form the fluorides. The inert gas fluorides are formed. There are different types of fluorides, difluoride, tetrafluoride, hexafluoride, oxyfluoride, variety of compounds are formed by fluorine with inert gas. So, the question reads as the correct geometry and hybridization of xenon, xenon tetrafluoride. 4 choices are given, either octahedral or triangular planar or trigonal, bipyramidal or square planar. And then modes of hybridization also given, sp3d2, sp3d2, sp3d, sp3, like this. Here let us recall. So, octahedral structure is one where we have square base and 4 triangles each are drawn to the bottom and top of the center of the square. That is called octahedral. It has 8 vertices. So, here the hybridization, mode of hybridization is sp3d2. So, s orbital 1 orbital, 3 p orbitals 1 plus 3 4 plus 2 d orbital 4 plus 2 6 orbitals are overlapping. Another one, trigonal bipyramidal. Trigonal bipyramidal means triangular base. We have to choose a point above and below the plane of triangle. Once again, this has to be connected to the vertices of the base triangle. This is called, so above this upper portion is one pyramid, lower portion is another pyramid. The composite structure consists of 2 pyramids, trigonal bipyramidal. It has 5 vertices. So, s orbital 1, 3 p orbitals 1 plus 3 and d, 5th orbital. 5 orbitals, when they overlap, they occupy the 5 vertices of the trigonal bipyramidal. Once again, we see that sp3d2. So, sp3d2 may result in either square planar or octahedral structure. What is the difference is that the same mode of hybridization, different geometry, because here sp3d2 may be, the d orbital may contain electrons. D orbital may contain electrons. So, the orbitals which contain electrons, if they overlap, they may result in octahedral structure. Here, xenon configuration or inert gas configuration is S2p6 in general. Inert gas configuration, valence shell configuration is S2p6. Outermost s orbital contains 2 electrons. There are 3 types of p orbital, each of which contains 2 electrons. So, 3 2s are 6 electrons. So, yes, it is octet structure, 2 plus 6, 8 octet structure. So, it has no electrons in the d orbital, but higher, so helium, neon, argon, krypton, xenon. So, 1s1 is 1s1, 1s2, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 4p6, it can be. Here 5s2, 5p6. After 3d orbital is there, 3d orbital, 4d orbital is there, 5d orbitals are there. So, here the d orbitals are there, but they are empty. So, that is to be noted. So, 5th shell means it will definitely contain orbital. 4th shell means it will definitely contain orbital, but the orbitals will not have electrons. That is called unfilled d orbitals or vacant d orbitals. So, presence of vacant d orbital, its hybridization takes the different structure. That is why it may be octahedral. So, if the d orbital has electrons in it, it may result in octahedral structure. If the d orbitals are vacant, such orbitals, vacant d orbitals may coalesce or hybridize to form square planar structure. So, triangular planar, square planar structure means merely the square, 4 vertices of the square are occupied by the different orbitals. That is to be noted. Here d orbital is only vacant, so no electrons in it, just it will form. That is the reason behind. So, these are the arrangements for the different one. Here XeF4, that is xenon hexafluoride is nothing but the actual structure will be in this form. 4 fluorine atoms will be along the 4 corners of the square. Along the 4 corners of the square. The center of the square will be occupied by xenon. So, if at all any orbital is there, that will be above this or below this. But here there is no electron. It is only orbital. Orbital means it is the space where the finding the probability of electron is more than 0. Probability of finding the electron is 0 means no electron, no orbital. So, if the probability of finding the electron is 0, such orbitals are called vacant orbital. So, it has vacant d orbital. So, its structure is square planar structure, but hybridization is sp3d2. Yes, sp3 in the say all are in the 5th or 4th shell, whatever be the case, inner shell or valence shell, whatever be the case, but they are vacant here. That is to be noted. So, this is the arrangement. For this case, octahedral is not there. This is possible only if the filled electron d orbital overlap. It is not there. So, octahedral. But d orbital overlapping is there. Here also the question may arise. Here also d orbital is there, but it is vacant d orbital. So, vacant d orbital cannot overlap. Here, if what is meant by cannot overlap is that trigonal bipyramidal geometry arises due to the overlap of d orbitals with 1 or 2 electrons. That is to be noted. In all these cases, d orbital contains at least 1 or 2 electrons. At least 1 or 2 electrons. Here, no electrons. That is to be noted. So, for this structure, square planar structure. So, square planar square, center of the square is occupied by xenon. 4 vertices of the square is are occupied by fluorine atoms. Total molecule is a planar molecule. So, as usual, the dotted lines denote the geometry. There is no linkage. So, it has to be carefully understood. Otherwise, fluorine may appear to be having 2 valency or more than valency. Fluorine valency is only 1. So, it has to be attract. So, that is to be noted. So, this explains the nature of the thing. So, 4 corners are occupied by the fluorine atom. So, for this question, correct choice is square planar structure and sp3d2 orbital. sp3 4 orbitals or overlapped orbitals are occupied by 4 fluorine atoms. But 2 d orbitals, they are lying vacant. That is to be noted. This is with respect to this question. So, as far as once again to completely repeat the question and answer, the correct geometry and hybridization of XCF4, xenon tetrafluoride, is square planar geometry and hybridization is sp3d2. sp3d2. So, the square planar vertices are occupied by fluorine atoms, center of the square being occupied by the xenon atom. It is to be noted.